We're down to the last two segments involving graphics assets within the Traffic Department archive. This time we'll pull out the menu graphics by building a utility based on our approach to the SCR files, with some slight modifications. We'll use a hex editor to gauge the dimensions of the MEN and SSS files before programming up our solution in C. Let's go to PowerShell to build the workspace and copy the two graphics archives and the menu default palette. Again, we have to rename the archives with a unique base name since the extensions will be the same after we convert them to bitmaps. We'll copy a makefile from one of our other workspaces. Before programming, let's take a peek at the source archives with the hex editor. We'll start with the menu, open it up to 32 width, set the offset base to decimal. No palette, so we'll have to rely on the default. Still a bit sparse, so let's move the encoding to DOS. Now, it looks like these repeating sections are a lot wider than 32. You know, we've been down this road enough already. Let's try the game resolution width since we know this has worked out several times in the past, and we know the main menu is at least as wide as the game screen. There we go. We can even see letters, so we know that this asset is 320 pixels wide. Let's check the other asset file with a width of 320. Well, it doesn't make much sense, but it could be something if we try converting it. Now, there weren't any indications of multiple images, so let's just build this out as a single image. This means we'll rely on the SCR file utility as a basic resource, but we need to alter it to handle images of fixed width and arbitrary length. Alright, let's do this programming thing. We'll open the SCR utility in the right window. We'll make changes to the makefile on the left. Now we'll create a new source file and save it. Give it a description. Copy everything down to main. Now the work outline is a little different. Unlike SCR files, we need to figure out the file size and number of rows before we can create a surface and begin processing. So the outline is, open the files, find the file size, calculate the file metrics, make the surface, pull the palette data, pull the image data, rename the files, and finally save the bitmap. First, we'll open the asset in the default menu palette. Declare the file pointers. Then we'll find the file size. Declare that. Grab the file metrics. Declare them. Create the surface with the new variables and declare them. Get the palette from the default palette and close the file. Declare the index and array. Now we'll do the same routine to pull the image data and match to the palette. We have to change the loop condition to account for the arbitrary image size. Declare all that. Nothing else changes, so we'll go through this. So we'll save and build. And there's the obligatory error. Wow, I double declared something. All right, let's try that again. Build success. Let's run. Okay, this is taking far too long. Did I mess up the loop? No, it looks right. Is current byte overflowing? How big is this file? Ah, yeah, it should be 32 bits because at 16 the loop will never exit. Looks like this video is more about troubleshooting C. Alright, that should do it. Okay, time to revoke my programming license. Apparently there's a palette problem now. I forgot to change the pointer reference. We were using the image data as color data. That's probably why it was offset too. Alright, fourth time's a charm. One file contains the main menu, and the other contains the save and load game slot graphics. Now, before we wrap up, let's take a close look at the main menu. This actually resembles a texture sheet you'd find in a modern game, with some important differences. This graphic isn't really laid out in a way you'd expect in modern UV processing. The top part of the graphic is actually two half-size interlaced graphics. What happens is that the image is drawn centered on the screen, but it sources data starting in the top left of the image. As it reads across and hits the halfway mark, the destination screen changes lines, but continues reading to the right from the source here. At the end of the line, both destination and source pages are ready for a line change. Now the main menu is the same except for the colors of the letters, which I'll get to in a minute. The info bars here are at full length or just drawn centered on the screen separately. The next section is the same as the top section, interlaced images cut to fit the 320 width. Now the bottom part appears to be garbage because it's actually not image data, it's palette data. But we aren't seeing the palette as it's meant to be displayed because we're processing these data with the menu palette just like the rest of the image. In fact, this section contains the menu animation data that we see when we scroll through the text on the main menu options. Remember how the main menu text highlights and fades as we scroll through it? Well, that happens because these text values are unique colors, and the palette instructions at the bottom substitute these color references in our original palette to simulate animation. This was a very common approach back in old games for cheap animation effects. It had to reuse, and you could reuse the same sprites and get different graphics colors. To read more about how this works, research color cycling or palette shifting. And we're not going to use these palettes in our prototype, and I haven't decided if I want to go with this old school approach when we build the full engine later on. Thanks for watching.